All right, welcome everybody. Can you hear me okay? All right, it sounds nice and loud. So yeah, as Simone said, my name is Bob Paulin, and welcome to Growing Up Geek. So we've assembled a crack team here for you today to talk about kids and programming and technology, because first of all, it's a very current topic, and it's a very important topic. So myself, I'm an independent consultant. That's what people pay me to do, but I also run the Chicago Java Users Group. I'm an Apache Software Foundation member, committer in PMC on Apache Tika and Felix. I help run the GOTO Junior event, as well as the DevOps for Kids group here in Chicago, so very involved in kids and programming. And I'll let the rest of my crew introduce themselves.
Hi, I'm Sarah Johnson. I'm based in Philadelphia, and I work for a nonprofit called TechGirlz. I'll tell you more about them later. I'm a generalist in IT. I've managed tech support for companies, and I've been an IT department of one, which is always fun. You talk to yourself a lot. And I've been volunteering teaching adults and kids technology in Philadelphia, and involved in the tech scene out there.
All right, cool. My name is Tim Steele. I'm in Chicago. I'm with Bob. I help with the DevOps for Kids group. I was also a participant in the GOTO Junior conference. And I'm a software architect. So a lot of front end, a lot of JavaScript, a lot of Node. But that's what I do.
All right. So we're all here at GOTO, right? Is everybody enjoying the conference so far? All right. Me too. Me too. And here at GOTO, we like to talk a lot about the future. I mean, we heard a lot about it yesterday. We're going to hear more about it today, but this talk is going to trump all of them, because for what we're going to talk about, there's no Gartner hype curve for it. We're off every tech radar imaginable. We're talking about things that could be happening 30, 40 years from now. One thing that's just very apparent to me is that the kids growing up today are growing up in a very different environment than we did. We grew up in a very different environment from our parents, and these things just keep accelerating. So some of the points we're going to try to make is this change in environment means that as parents or educators or people that are involved in the lives of children, we need to rethink how we're doing things as well. We want to be able to make sure the kids can be successful and good citizens in this society that's coming up, that's changing so much. So first of all, and I don't think it's a hard sell to this crowd, you guys already get technology. You're here at a conference talking about technology, so you obviously very important. But we're also hoping that we're going to expose you to some of the resources that are out there for you as parents, as educators, as people interested in children, to help get you to that spot where you can place a kid in a program and they can have success and find the right mix so they are interested in technology, and that inspiration and interest can grow over time. So I'm kind of curious, though, where this audience is at as far as so who here has kids? All right, got a lot of folks with kids. So we all know we love to brag about our kids. So I'm going to ask some questions that is going to allow you to either to brag about your kids a little bit. So how many people in this room have kids that are fluent in going to websites and they can use the internet? All right, a lot of hands go up. How many kids have actually built a website? Have kids that have built a website? All right, we got one. How many kids or folks have kids that use smartphones and they're fluent in using smartphones, swiping, just playing games? Yeah, right, a lot of them. How many kids have built an app? One. All right, there's one in every room, and there's the proud parent with the hand up. It's like, yes, my kid has built an app. I win. But what I'm trying to highlight is we're very technical savvy people, and most of our kids are really user or consumers of technology, right? A lot of the UX that's gone into devices these days, it's made things easier to use. But we still need people to produce it. We've got so much code out there now that maintaining it is actually going to be a huge burden that they're going to be shouldered with. Who actually believes they're going to be writing code 50 years from now? Okay, my hands, oh, okay. Very good, it's glad to have you. But for most, I think most of us are probably going to be a little bit out of our mental prime at that point, and we're going to hope that other folks are going to be able to pick up that ball and carry it. But I think we've got some problems, and Tim's going to talk about some of the issues that we have today with our society and with how people understand technology.
Thanks, Bob. Yeah, so with our society, most people, as the slide says, most people don't understand technology. We start with our government. Our government struggles with technology. See, a lot of you already kind of know where this is going. So we can start with the VA and the Department of Defense, where they have a $27 billion project to try to get their two systems to just talk to each other, and they abandoned it because they couldn't figure it out. Or we have the Office of Personnel Management, which had over 20 million government employees' information exposed in a hack because they're using outdated software, they're not using encryption, they're not using multi-factor authentication. Stuff that, most companies, at least mine, I just need that to get onto the VPN. We can go with our legal system. I think this is the big one that's been most recent, is we have the Apple versus the FBI. And that's a very important case that involves encryption. Now, whether you're on the side of the FBI or on the side of Apple, the question of whether the government should have access to encryption, you need to understand technology in order to properly answer the question and understand the ramifications on both sides. We have Google versus Oracle. This one is actually, they're having their final arguments this week. And this court case is, can you copyright APIs? And the biggest problem that this court case has, they can't explain to the judge and the jury what an API is. They have Google bringing in filing cabinets, trying to explain it using this. You have the judge talking about it as a library. And the people that are deciding the future of software development with APIs, they don't even know what they're actually deciding. And then we have our local communities as well. So this is my favorite. Unsecured Wi-Fi. 28% of Wi-Fi is unsecured. So you guys are off the hook, but you guys over here, look around. Statistically, one of the people around you is using the default admin password on their router or using unsecured or giving away free bandwidth. This is another fun one. Can anyone tell me what the #1 password is for people? Any? What's that? Password. So #1 password is password. Do you know number 2? 1, 2, 3, 4, 5, 6. It requires 6 characters.
Oh, that's the number on my luggage.
Yeah, exactly. So the question is, we're talking about kids. What's standing between your kid and your App Store password and an unlimited supply of mega points? Is it the word password or 1, 2, 3, 4, 5, 6? So really what we're talking about here is that we're going to need better digital citizens for our future. And to talk about that, we'll give it back to Bob.
Yeah, so I mean, and this stuff starts at a very young age. It comes down to like how we're starting to socialize our kids. And most of us remember growing up, many of us grow up with sports. So this is a model that makes sense to us, right? So sports are great, and this is not to knock sports. They teach teamwork. They can teach you courage. They teach you perseverance. And we all have those experiences where, we get knocked down and we get back up. We have that experience where, we're losing and we believe that we can come from behind and we prove to ourselves that we win. Even against perhaps a more talented team where, just having that grit solves that problem for us. And I completely bought into this philosophy. So, I mean, as a football player in high school, like, I was a little runt on the team and, I went to the gym and I bought in that if I put in the work, it would happen. And by the time I graduated college, I was a 2-time All-American. Now, these things can happen when you buy into that philosophy. But then I graduated, and I found out that the real world is very different than the sporting world. So there were some gaps that I realized. And sports, by nature, are kind of adversarial, where I'm basically encouraged to destroy the other team by as much as I can, and by doing that, I'm rewarded. However, in business, whether you're trying to go for a promotion or you're trying to do partnerships with other companies, in general, you're looking at win-win scenarios. We actually benefit by working together more than we benefit from trying to beat each other up. We all get hurt when we try to beat each other up, but when we work together, we all benefit. Now, I saw this coming out with open source and how open source works, and I just saw it just in social environments within my workplace. So it took me a while to learn these things, because you come out with one model that says, hey, this works, and I'm just going to apply that tool everywhere. Well, it doesn't actually work that way. So how can we get our kids to start understanding how the world actually works younger so they don't have to go through that pain? You know, still do sports, but there's other things we can be doing as well. And now Sarah's going to talk about some of the other things that prevent people from doing these types of programs.
So your kid's not a genius, and chances are you're probably not either. Definitely not a reason for them to avoid learning about technology. It's great to recognize geniuses for their exceptional work, but in reality they're successful because of the team that's supporting them. Google did research on how to create the dream team. So you figure pick a bunch of great people from history, put them together. To quote the Google research, take one Rhodes Scholar, 2 extroverts, 1 engineer who rocks at AngularJS, and a PhD. Voila, dream team assembled, right? They found out that they were completely wrong about what makes a good team. It's not about the people as individuals, but about how they work together and how they can support each other as a team. So it takes all kinds to form a good team. You know, you need them to work together, but you also need a diverse set of skills. There's a lot of misconceptions about technology expertise and what skills someone working in technology has. We all work in IT, so we can all remove a virus from an infected computer, right? Help all of our parents and friends. Yeah, let's talk about it in terms of a house. You have a leak in the kitchen sink. Who should you call? Plumber, right? You have a leak in the roof. Who should you call for that? Probably a roofer. You have a broken window. Who should you call for that? I have no idea. I've never had a broken window, fortunately, but I'm not going to call the plumber. I'm not going to call the roofer. I'm going to get someone with specialized expertise. The same way that we're going to do with technology now. Houses have been around forever, so people understand that. They know who to ask for help when they have a problem. But because technology is still relatively new for most people, they don't know who to ask. They don't know how to get help. We know that we can't fix everything alone. And we also know that we don't all enjoy every aspect of technology. How many of you don't do fonts or graphics, right? How many of you deal with databases only or DevOps exclusively, right? There's such a huge range of skills in technology and what it means to work in technology. And we're all attracted to it for different reasons. So the more that we educate kids on all the different aspects of technology and help them find that aspect that they like, that thing that will keep them engaged with it and creating rather than just consuming, the better like our society will be, the more roles we'll have to help support each other in technology. And who knows what's gonna interest them. So this all leads to how can we better prepare our kids, right? What can we actually do for our non-genius kids to be better digital citizens? The solutions are out there. Many are still being developed. But we have some ways that we'll suggest for you and your kids to get started if they haven't already. No matter what type of tech activity they try, though, be sure to get them started as early as possible and make technology part of their education, not just an add-on that they come to later. So, Bob, you want to start by?
Yes, let's start. So let's get into the meat. So this is our help session, and we're going to go through a lot of the different things that are out there. And again, depending on where your kids are at, some things might fit better than others. So we're going to work through all those different things. And the things I want to start with is the one-time events. So this includes the event that we did on Sunday with Junior GOTO. And this is my experience with fonts. So that's Comic Sans. I just put that on because I didn't see a Junior GOTO logo. So hopefully the people at GOTO are all happy with that. Use it if you want. But these events are the entry-level events. So the one-time events are focused at my kid has no programming experience, my kid maybe has that consumer experience, they can use a laptop, they know what keys are, they know what a mouse is, but in general, they're not they're not producers of this technology, right? They don't understand programming logic, and that's okay, because what these are here for is there to inspire kids to want to do more. These sessions generally focus on making the kids successful by giving them quick wins and allowing them to kind of experiment with the technology that they're using. So one example is we did Minecraft modding. So Freddie leads a Minecraft modding class, and he's here in the audience. And the way that works is there's modding kits that are available. There's scripts that they run to decompile and to create the modding kits. And there are basically code that they can copy and paste into the IDE. We are completely realistic. We're not going to teach kids object-oriented programming in 3 hours, which is about how long these events usually last. So they're brief. So if your kid ends up absolutely hating technology, that's okay. It's 3 hours of pain. You didn't sign up for a full season of it. You don't have to wake up at 8 a.m. There's no traveling to other states. It's brief. It's generally painless. And you kind of get a beat on whether this is something they'd like to continue to do or not. The big focus is on letting them take something away. So, I mean, the beauty of the way the course works, and we got this course from Arun Gupta and his son. So, I mean, the other thing that's kind of cool about this is sometimes the kids are actually generating and creating the course material and leading the course material. But each one of these kids goes home with a laptop set up for Minecraft modding. So we're heading into summer, and kids need things to do over the summer. And sometimes it rains outside. We do live in Chicago, right? Good indoor activity, yeah, why don't you go play Minecraft, and why don't you do some of the hacking? I mean, it's amazing to watch some of these workshops when these kids learn that they can spawn ender dragons at will. And then they find out they can spawn 2 and 3. And then there's this thing called a for loop, and they can put a big number in there, and the dragons just keep coming out. It's really amazing to see that, because the eyes just light up. It all clicks, and it's like, I can do that? Yes, you can. So, that's kind of the goal of a lot of these things, and the Minecraft modding is just one example. We had one with cryptography that Sarah led, HTML5, which Tim led, but every kid walked away with some skill. They didn't understand all of the things that were going on around it, but again, they were inspired and they saw the power of learning these things. Because, I mean, I'm a typical boy. I got into computer science because I wanted to make games. I mean, how many guys in here got into computer science because, I want to build video games? How many of us are actually video game developers? All right, well, we got one sort of, so it's like, that is like the gateway to computer programming for most little boys. So for getting them into that. There's other classes out there, such as Alice, that we're going to be looking to host in the future, and that is more storytelling. And those are more focused on getting more girls involved. Sarah will talk a little bit more about that on later slides. But, again, the goal is to inspire. This is the entry-level course, but let's say your kid goes to one of these events and loves it. What do I do next, Sarah?
Well, there's...
here's some pictures, too.
Yeah. Great photos and anecdotes. We could go over that all day. So I'm going to talk a little bit about TechGirlz first, because we're similar to the DevVox for Kids things. We have one-time workshops. They're introductions to technologies for girls, the 3-hour workshops, and it's really what I talked about before. It takes all kinds. We focus on the breadth of technology skills. So the workshops that we have that anyone can use to run a workshop anywhere are topics like we have Alice, to create stories and animation. Same thing with Scratch and a lot of the sort of kid-focused technology that you've heard about in the HTML and all of those. We also have them install Linux on a computer, take computers apart, what's inside a computer. Literally, here's an old computer and a screwdriver, have fun, and show me these parts. And then some robotics ones, user experience design, mobile app design, and as well as mobile app development. So again, trying to find what's that aspect of technology that's going to get you interested to learn more. So we term these the national organizations because they are ones, in addition to TechGirlz, but most of these have a very structured organization. They have teams, and they're going to be much more intense time commitment and much more in-depth learning than the single event options. The ones once you know that your kid's interested in this and they won't get off the computer and stop making websites or dragons in Minecraft, where do you go from there? And these are some of the options that are out there. Again, it's still kind of new. There's still a lot that's coming up. But I'm going to start with Coder Dojo because it's most similar to the DevOps for Kids and the GOTO Junior workshops that we did, where it's taking an aspect of programming generally, sometimes with a little bit of hardware like Arduino and Raspberry Pis, and they do like a monthly coding club, but it's very free form and it's very individualized for the kid. Usually run at a library or something. These are global. They're based out of the UK, and they have chapters all over the country. There's 2 in Chicago, 200 in the US, and 1,000 global Coder Dojo groups. Somebody can say, I want to start one. I'm going to meet at the library on Tuesdays once a month, and kids can come in and we'll work on whatever they want to work on. We'll work them through Scratch. We'll give them like, one-on-one mentoring. So that's really good if your kid's interested in one specific thing, and you don't have to sign up for it, but it's there every month and you can keep going. And if you're traveling with your kid, you could probably find them in other cities as well. First Robotics. How many people know about First Robotics? Oh, wow, I'm glad you're all here because they're awesome. They do so much. They are primarily in schools, and Bob, you're going to correct me if I get any of this wrong because I haven't volunteered with them, but they're primarily in schools, and they range in ages from kindergarten all the way through high school. They have organized challenges. They start out with like grades K through 3, where they give them a real-world problem, and they work with Lego Mindstorm robots to sort of, how would you address this problem in a very creative kind of way. As they progress into grades 4 through 8, they work on real-world problems with Mindstorm robots, but then they compete against other schools. As they get into 7th grade and up, they can do the technology challenge, where they program robots to complete challenges. I think it's tabletop for like the junior high level. And that goes through high school, but that's really focused on the technology aspect of it. Like, what can this robot do, move through an obstacle course, things like that. And then the sort of the ultimate one is the robotics, the high school ones is the robotics competition, where they're actually working with industrial-sized robots, and they compete head-to-head, and they have like local, regional, and then do they have national competitions as well?
Yes, they do. I mean, and if you don't mind, I mean, so the one thing about First, and one of the things that we talked about earlier is sort of the philosophy, again, the mentality that some of these organizations build around sharing. And First embraces this as an organization because they have something called cooperation, where basically you are competing against other teams, but it's baked into the scoring that blowing out another team is not advantageous to you. So what the teams are actually encouraged to do is they're encouraged to share designs, they're encouraged to share knowledge with each other, and they're actually judged on this. So again, it's getting a lot closer to that real world model of how things actually work at companies. And one thing I did forget to mention is just, you know, volunteering at these things for technology professionals. It is super exciting because once you get into these programs where the kids are doing this on a weekly or a daily basis, they will blow your minds. I mean, some of the things that these kids are doing at like 4th through 8th grade, it's really impressive. It's autonomous robots. They are programming autonomous robots. They're using sensors. They're picking things up. They're manipulating things. The one thing I would add, though, it's like an actual sport. Like if you were ever involved in band or you were involved in an everyday type of sport, that's the type of commitment it is, which as a parent, like for me, it was like, holy cow, this is like way above where I was used to. This isn't just recreational, this is serious. So that's one of the major differences between that and some of the first-time events is there's usually commitment involved in some of this.
Yeah, and then for volunteers, especially, like you can help out like as a mentor with a team, with your kids, and that can be a huge time commitment. But at the same time, with the competitions, they need a lot of volunteers to help at the competitions. And so they say, like on their website especially, they have everything from like a one-day, you know, half a day opportunity to a full semester kind of thing. So some other things that are out there nationally. Oh, and sorry, for First Robotics, they have over 500 first teams within 50 miles of Chicago. So that's out there. The schools are really picking up on that because you buy some Lego kits for the little ones and get someone who kind of can figure it out and you're up and running.
Yeah, there's clubs and things everywhere. If you're interested, talk to me about First. I'm involved in First.
So I've got Apple and Microsoft up here because they run summer camps. They have multi-week camps for kids at their stores. So find a Microsoft or Apple store in your community and go ask them, what can you do for my kid? Get my kid into tech. We can do questions throughout this. So, for public schools, me personally, or I think the First exists in the public school if they have.
So yeah, First is usually a club sport, but I think one of the things that I've heard about, and I don't know if are you going to cover TEALs at all, or even mention them?
Yeah, a little bit, yeah.
Okay, so then I won't steal your thunder on that, but there are some things that are involved with public schools, but I think we'll touch on that a little bit later. I don't want to steal any of your thunder.
Yeah, but it's a great question. Yes, so. They have camps at their stores, and they have free workshops throughout the year that can be school field trips. And it's pretty much bring the kids, and they can use all the tech in the store. That's how that's their marketing angle. But they do teach them things. I know at Apple we've done like video editing, audio editing, making videos like with the smartphones and things like that. And then they really want to connect with the kids beyond just like using the devices, and do some mentoring in the schools and career exploration. And some of that is focused more on the girls' side of things because women in technology, we need more. Look around the room. But they also do TEALs, as Bob was mentioning, where they bring computer science volunteers into the classroom. And I didn't read on their site specifically about like which types of schools, but
there's one in Illinois. Yeah. I'm trying to remember what the name of it is. I think it recently changed, like DePaul. It was Lane Tech, I think, or no, I think it was Gordon Tech, and now they actually have a TEALS program. Yes. Yeah.
So I don't so much have a question, but it's a comment.
Yeah.
So I mean, there are awesome things out there, and I just want to say, recently it's dawned on me, right? So I want to share it. That we are the grown-ups now. So one of my buddies at work, for example, goes to, I am from Boston, to one of our more rough and tumble neighborhoods we have in Boston, and he has worked in that school so much, all right, and has brought so much into that school that school is like being taken off some super awful worry list that the Boston school system now has, all right? As in, you can actually, like us going and doing stuff there can move the needle, and our buddies will come with us. Yeah. So take schools, like he took the MIT Scratch course, which is free and like easy.
And we're going to get to that later too.
Yeah, no, thanks for bringing that up though, because you're right, we are the adults, and it is up to us to share what we know about technology. I mean, one of the facts that was on the TEALS section of the Microsoft website was that 9 out of 10 parents want their kids to learn computer science, and 1 out of 4 schools are actually offering computer science classes. And we're trying to change that. Chicago's working really hard to change that, in other cities as well. But the reality is it's not there. We had a kid in the encryption workshop, a little 8-year-old. He's like, when are we going to learn this in school? I was like, you're not. I'm sorry. Not yet.
Not yet.
Maybe
no,
one day.
The Chicago Public Schools did pass something that they are going to start making requirements around computer science schools, but that's super recent.
Yeah. And then also, we're talking kind of about national organizations and the really organized stuff, but again, like your local school, like just talk to them, ask them what you can do. Some of them have very strict volunteer requirements, but sometimes there's ways around that with like, if you have a teacher in the room with you, you might not have to get the full range of background checks. It depends on the school. Yeah. That TEALS program, they said, you can co-teach in a classroom with a teacher 2 to 3 times a week, and they estimated that's about 280 hours a year. But you can also be a TA once a week, or you can consult with the school and and help them figure out how to bring technology into the classroom, how to enhance their technology education. The way that this slide is organized is the first row is the sort of co-ed activities. In the second row, it's all girl-focused, because that's what I work in. So Technovation Challenge, if you haven't heard of that one, is, again, it's for girls. It's focused on high school, but it goes down as low as middle schoolers. And they have an apps challenge. They have the kids design a mobile app, come up with a real-world problem and a solution for it in the frame of a mobile app, and they not only like design the app and come up with a business plan, but they actually develop the app, at least like a working prototype of it. And they have to have like a pitch and do a video and submission, and it's actually a global competition. There's a pretty cool movie about it. So that's a really fun one, but again, it's like a 3-month competition, and as a mentor, you have to devote a certain number of hours a week. The kids have to devote at least four hours a week, I think it was. And it can be very involved, but if they're getting into they want to learn more about how to make apps and how to use this technology, it's a great place to go. And that one can also be, teams of like 3 to 5 kids, and they just need like a mentor. They just need your help to make this happen. Girls Who Code is another more in-depth one, where they have a 6-week immersion program in the summer, where they, again, are teaching girls web development and mobile app development, and they actually bring them like 2 offices and 2 technology offices, and I think I don't know all the details of how they're doing it, but really getting the kids interacting with technology professionals so that you can say, oh, I see myself being that person. I see myself being a technologist eventually.
Yeah, and I can speak a little bit to that because I run a girls' school camp back where I live. Usually this is done on like middle schools or high schools, and you collaborate with them. So you find a teacher there that wants to sponsor for the school side. You have to be a professional, a computer science professional, to be teaching these classes. It is interesting because like we actually had to do a test. And they asked me big rotation and recursion. Like, all right, this has been the toughest interview after a while. But the thing is that it's exciting because that is essentially how you influence. Like the Girls Who Code program works with the school for you to bring that to the kids in the school. So when there was a question asked about public schools, this is one of the ways. This organization will do it, and like it's not necessarily in the summers. Like we just finished, I guess just finished, actually that was year round. It was just a whole school year. We were doing 1 hour every week about, working on these workshops. We started to Python, then moved into to HTML and CSS. A lot of it is self-driven. So mostly what the purpose of you being an instructor is if the kids get stuck, if the girls get stuck, and mostly just to give guidance. It was interesting just to tell them, like I have one of my interns, leave for, just moved to another company. And the guy just had 6 months of experience and he got a $100,000 offer for working for Pixels. So once you start going, it's like, what? Yeah, you will be employed, especially in Chicago.
Yeah, and so that's the other side of what Girls Who Code does, because they have the 6 or 7 week immersion program during the summer, and then throughout the year they have semester-long programs that are like 40 hours a semester, like once a week or something, and you need to, and you get tested. It's interesting. So, and then the last thing that I have up here is the Boy and Girl Scouts. A couple of years ago, my TechGirlz, we had talked to them, and they were like, oh, we don't have a badge for tech, so we don't want to, we're not going to do anything. And now they do, both of them. And I was actually impressed by they have like entrepreneur badge and like digital media and some just general like technology ones. So, if you have a kid in Girl Scouts or Boy Scouts, or a local troop, like approach them, because a lot of this is driven by the troop leaders and what the kids want to learn. So, yeah.
I'm on our local troops committee, and one of the requirements now for Eagle Scout is that you go through digital safety.
Awesome.
That you have to redo every year, just how to be safe online.
You should use the encryption workshop we have too, because when they say digital safety, they're like, don't post your address on social media. Yeah. I'm like, dude, there's so much more. So, cool. All right, I'll let Tim go on to other options.
Right. Yeah, I'm good. I'm mic'd up. All right, and the final one, you. So we kind of got into this, but this is the stuff that's not necessarily an organization or a nonprofit or something working in schools, but stuff that you're doing at home. So first one, I have a 15-month-old daughter at home. And they talk a lot about, what do we do in those early years, right? And some of the research that's come out is very limited to maybe even no screen time for the first 2 years. It's early, they're learning the environment around them. So how do we get started? Well, a lot of that early learning is exploratory. It's not structured. It's not a structured environment. You're not giving them a kit. You're not giving them instructions. And if you think about it, you hand a 15-month-old something, the first thing they do is they look at it. And the second thing they do, yep, right in the mouth. They're learning about it, and that's how they do it. And sometimes they say this doesn't taste like anything. Sometimes they say this doesn't taste good. Sometimes it's dog food, and they learn not to eat the dog food anymore.
Or they learn to eat the dog food.
They learn to eat the dog food. That's right. Point is, it's very exploratory. And, Legos, Duplos, Kinects, these are all the sorts of activities that are very exploratory, but they start to build the foundation of the thinking. So there's actually research that just came out recently about using Legos for creativity. And they found that if you're a free builder, meaning that, you and your kid, you sit down, you dump a big bucket of Legos out in front and you start building. Just that free building starts to promote creativity and problem solving in kids and actually adults. So when you sit down and play with them, you're getting the benefit too. And so, that's really good for those young kids where you're not getting a lot of that screen time and a lot of that immersive technology, but you're starting to learn the fundamental skills as you get older. And that's the next stage. So what do you do when you start to get a little bit older? And this stuff, this is where it's sciencey. You start to get into the science stuff of it with mom and dad's help, but it's disguised as fun. So squishy circuits is fun. We actually do this at DevOps for Kids, for the younger kids, and you build conductive Play-Doh. So you take this Play-Doh, you mold it into a, whatever, an iguana or whatever, and that's the, not the conductive, but the insulator.
Insulator, yep.
And then you make the eyes the conductive part, you hook it up to a little battery pack, and you put LEDs in them, and you turn it on, and the LEDs light up, and they start to learn about the electricity and how circuits work. And that's all. You find the recipe for that Play-Doh online. You find the instructions. You can find the battery packs. I think you got like 30 battery packs for like $5 off of Amazon. So all this stuff and is really easy to get a hold of and really easy to do. And like I said, it's stuff you're doing with mom and dad. So you're doing it together. Little bits. This starts younger. It gets into the older groups, but it's basically modular, electronics. So you can buy an actuator. You can buy some lights. You can buy, you can build machines, you can build software, whatever, but you just hook a bunch of pieces together and it's a creative way to build electronics. And, like I said, they have it for different ages, so the older kids can get into some of the more advanced stuff. The little kids might, that's just they're working with just lighting things up. So that's another good one. And then Scratch, we talked a little bit about Scratch, and this came out of MIT. And, how many of you here are programmers? All right, so pretty much everybody, right? Programming, it can be extremely frustrating when you miss a semicolon or, you get into an infinite loop or whatever the case is, and you're banging your head against the keyboard trying to figure out why it doesn't work. Okay, that's the adult stuff that's not necessarily fun to do when you're 5. However, with Scratch, you're not necessarily learning the syntax, but, we have the Frozen one, and I know you said your daughter loved the Frozen one, but you're telling Elsa, skate forward 40 inches or whatever, skate forward 40, turn right, and you then skate, 20, and you make her do a box. And you're learning to structure it and the loops, and you're getting into that structural thinking that you need with programming. And so you start to get into that older generation where it's mom and dad's help. So then, on the third group I have is what I call the hungry for more group. This is after your kids kind of got the hook. They've been to a couple of these organizations. They've done some stuff at home. They're maybe part of the national organizations. I try a couple of the events. And so this is the stuff that's a little bit more involved. It's a little bit older kids too. It's not stuff that's necessarily mom and dad. They may ask for your help, but Code Academy has code on a bunch of different topics, a bunch of different languages, and it can teach you programming. It can teach you some of the more advanced topics. Code.org is another one. It's very similar. It's a nonprofit. They're trying to actually get into the public school system and try to make computer science a more required national thing. And they're kind of, like I said, same vein as Code Academy. Battle Code, this one's actually fun. I spent a little bit too much time last night. I was up a little late getting really interested in this. So this is another thing that's out of MIT. How many of you know what Battle Code is? None of you. All right. You do. So this is neat. So it's an actual MIT. It's an actual course that's at MIT. It's an actual competition. And the course is 4 weeks. And all it is you basically build AI. And you build every single, they virtualize robots that they load, however many robots with your AI, and they got to work in unison to, go back to sports mentality, beat the other team who's developed their own AI, right? And then you go in and you have objectives and you know, all this stuff like that, you conquer or you try to do all this stuff. But the whole thing is open sourced and available online if you search for battle code. And they give you instructions. Here's how you follow our lectures here, follow our instructions, and you can have your own AI battle bot, like virtualized battle bot up in like a couple hours or whatever like that, and then you can actually participate in the competition. Like it's a national competition. They have a special one that's for the MIT students. That one's for scholarships. But then they have another competition that's for prizes and everything like that. That's open for everybody. So kids. Scholarships,
Parents,
yeah.
Like, yes.
Taking notes, yeah. And a lot of this stuff too, the battle code thing, a lot of your tech entrepreneurs, they were listing out all the people who came, like Dropbox and all these things like that are battle code like veterans. And they come back to these events because it's such a huge thing, because they teach, you work in teams of four, so you learn teamwork, you learn how to think, you learn strategy, you learn coding, all this stuff like that. So it's a little older, but still, it's an amazing thing, and this is all stuff that you can do at home. You don't need to join an organization. You're talking about hacking during the summer, it's a rainy day. This is stuff that your kids could be doing today. So, and I'll let you finish off the last slide here.
Alrighty. Yeah, I mean, so this room is a great slice of the Chicago developer community, or people from all over the world that can make this stuff happen. So we're all at these conferences, and we're all trying to figure out what's coming next, right? What is going to happen in the future? And what it is we make the future. These things that are out there influencing kids to get involved in programming, whether it's self-driven, whether it's with one of the long-term organizations, or whether it's just, kind of getting the spark at one of these initial events, it's up to us to make the future. So it's, if you want to know where programming is going in the next 20 years, get involved in this stuff. I mean, they're looking for volunteers. It's a lot of fun for technologists being involved in this stuff. And if you have any questions, if you're trying to find out more about these organizations, again, we have a crack team up here that has a very broad experience with them. And with that, that's all we have. We've got some references, and do we have any questions? So let me ask you guys a question. Who is involved in any of the stuff that we mentioned, or does anybody have anything that we didn't have up here that they'd like to mention? Yes?
Vex Robotics.
Vex, yes.
Is almost, or maybe bigger, depending on how you count, than First Robotics, I think.
Yeah, they're a fork. It's political, but yes, it's really very much, it is definitely a thing. And I volunteered at Vex. It's a different opinion on it, right? So Vex makes you buy all their stuff, which is great because most of the stuff then works together. They kind of taken the Apple philosophy with bot building, whereas in First, you see a lot more like 3D printing and kind of like they're a little bit more loosey-goosey with the rules. So again, depending on what you're aiming for or what's close to you, both Vex and First have very, very similar values, and they actually started off as the same thing, and then they just kind of forked off a little bit because they had different philosophies. But all that stuff is good.
We do actually have one question here. What would you suggest for younger kids, like 3 years old? And we kind of talked about like the squishy circuits a little bit because you're playing with Play-Doh, and that's really fun. I don't have kids, so my analogies are sometimes off base, but I'm like, cats are using tablets, so let's get 3 years old, yeah, you should be on the tablet. But I think things like Scratch and Blockly, where it's drag and drop, and you make like a character move across the screen by moving puzzle pieces that actually contain code and interlocking them, that gives like a great reward for the younger kids. They see this little, in Scratch, it's this little like mouse or thing that moves across the screen. So the 3 years old might be able to get that depending on the kid.
I think go ahead.
So yeah, with Scratch, the thing we've seen is usually at that kind of age group, they definitely need mom and dad's help. And the reason for that is the reading skills. I mean, turn right, turn left, that kind of stuff like that. They're kind of bigger words, a little bit more sentences. And so, it can be a little bit of a struggle. Not to say that they can't do it. It just usually requires what we call pair programming in order to do it. And so that's the time investment, sitting down and going through it. But it's definitely something that's done, and we've seen it done. Even at our organizations when we do Scratch, I think we've had kids as young as 4 in there with mom and dad's assistance.
Yeah.
And so we have that, Scratch. Squishy circuits, that one's always good. Kids love that one. Like I said, because then when you make the Play-Doh, it's not, we buy it in these little tiny cups, and you get this stuff and it dries out quick. You make batches about that big. I mean, that's one batch of the squishy circuits, and that's like, here's your conductor and here's your insulator, and it's massive, and so you have a lot of Play-Doh here to play with. And so, like I said, they can make things, and then you can get in different things, little motors, not just LEDs, and so that one's always good. And then, still, you're in a little bit of a transitional phase, and so still sticking with some of that stuff, your Legos, your Connects, that kind of stuff, and getting into the free building. I have always thought web developing and programming is just, Legos for adults. It's the same stuff, and with this stuff, that's always good to sit there and just, see. With my daughter, it's just start to structure the towers. I mean, how big can you get? And then it falls over, and then why? Problem solving, like that kind of stuff, and kind of getting into that challenge mentality.
Yeah, just to get more into the pairing thing. So I've done this with my kids at a younger age, with Alice, because it is more of like a storytelling type thing. Is your kids have the imagination, you've got the programming skills, so just letting them see under the covers the stuff working at least gives them that appreciation that, oh, when I'm watching a Pixar movie, a lot actually went into what we were doing, and some things are harder than others, and they can actually see that in the code as you're rolling by with it. Again, at that age, it's really more about inspiration and showing them that it's fun. You don't want to frustrate them by why don't you understand what a for loop is? No, that's, again, at the younger ages, it's more about just kind of showing them how powerful some of this stuff is. I mean, we've all gotten sucked into it. It's just articulating that to them. It's like, look, it sounds boring when you just see me there on my computer typing away to the late hours of the night, but really, this is what I'm doing, And you show them a video game or something like that. It's like, oh, is that what you do all day? Uh-huh. We spun up a Minecraft server, and just starting jars was exciting for my son because he's like, oh, this is what you do all day? It's like, yeah, I start jar files. Yep. Not lying entirely. Any other questions?
So you can now run your Minecraft server on a Raspberry Pi. It's just the instructions just work, right?
Yeah.
Google it. It was just pretty crazy.
Yeah, we used AWS. It was painless. He knows shell now. He's SSH. Okay, I don't need to show him bash scripts. All right.
And with the Google the instructions, I guess, throw one more final thing is for DevOps, all the stuff that we're running, all the workshops, they're open source.
Yes.
So, we decided Chicago, we needed a DevOps for kids organization in Chicago, and so Bob and I started, okay, how can we do this? And Freddie, I know that you helped out as well. And so how can we do this? How can we start this thing? Boston, you can bring, I don't think they have a Boston one yet.
I don't think they got a map.
Yeah, they have a map. But, I mean, that's the thing. This is all there, too. So, go home, get a couple of your, tech buddies and say, hey, how can we start this here? Here's all this, here's all the instructions. Here's how we can run a workshop. You don't even have to come up with a lesson plan. It's there. And then you start thinking about, well, what if we did this lesson? And then you start building your own thing and contributing back. And so really, it does start with you.
Yeah, it all just takes energy. I mean, the first time you do it, it'll probably be rough. But then the second time you do it, it'll get easier. And the third time you'll do it, again, it just gets better every time you do it. The main thing is just getting the energy to do these things and seeing that it is important.
Yeah, and that's one thing that I've been telling parents. I'm like, well, if the kids are having a play date, add some tech to it, Throw out a workshop plan. Let them play around with something. It doesn't have to just they're playing with tech. These are the new toys. And as you said, we're seeing high school students, teenagers who have learned a little bit of this stuff, and they're like, can I show someone else? We're like, yes, please do.
Scholarships.
Yeah, we have a volunteer at TechGirlz who is 16, I think, and she turned volunteering with TechGirlz and running workshops. She ran her own technology conference, she organized it and everything. That became an internship, and she's getting independent school credit for it now. So, yeah. Yes. have fun. Let them have fun with it.
All right. I see Simon over there. It's like you guys are at time.
We are out of time, actually, yes. So remember to vote, and let's give a big applause for the 3 speakers.